Okay, so this honestly is going to be the easiest unit on a multiple choice test. Because remember, guys, that you know a whole bunch of things before you even get started. So if I ask you to graph this thing, tell me what you know about this graph before we even do anything. It's got to be up like a cup. I bet you anything, there's probably going to be one that's down like a frown. You already know that that's not the right answer. What else might you know?
It's narrow.
Yeah, if A, the bigger A is, the more narrow the graph gets. So it might be hard to see that depending on the scale that they're using. And 2 is not that much bigger than 1, so it doesn't look, like if it was 20, it'd be super narrow, right? But anyway, so I know that this is supposed to be up like a cup, and I also might know that it's going to be a little bit on the narrow side. Okay, the other thing I would love for you to be able to find is the vertex. Do you remember how to find the vertex if you're given this? That's it. So vertex, you do negative b over 2a. That gets you the x coordinate. Okay, so that will get you the first part of it. It'll be at that number, comma, something. So let's do it for ours. Negative b over 2a would be negative 4 over 2 times a is 4, so I get negative 1. That means my vertex is at negative 1, comma, something. How do I find the something? I take negative 1 and I just plug into the equation and see what comes out. So if I very quickly pop in a negative 1, that'd be 2 minus 4 minus 5, negative 7. This one? So, well, that's the negative b over 2a.
Oh.
So you get that number, and then you take whatever that number is and you put it in the equation and see what it spits back out. So now, guys, it's multiple choice. I should be able to pick my answer now. I know it has to have a vertex at negative 1, negative 7, and it has to be up like a cup. If you still needed more, if there was 2 graphs that both had the same vertex and both were up like a cup, well, we have some options. Let me just grab a piece of, I'll just use, I should have just done their example. Hang on. Here we go. Okay. So, negative 1, negative 7. Oh, of course these grids aren't big enough. Oh, I'll just eyeball it. Okay, negative 1, negative 7. Do you remember how to get the other points? If I'm looking at this. Here's my original. Where do I go from here to get the other ones? So you normally go up 1, up 3, up 5. Right? But if A is 1, what am I really doing? Up 2, up 6, up 10 if you wanted. So then I'd go up 2 from here, over. By the way, if you forget the pattern, so that's up 2, then you would go up 6. So I don't even know where that puts me. Somewhere here-ish. Right? And I have this bloop, like that. So again, the normal pattern is up 1, 3, 5, and so on. If A is something other than 1, I'd have to multiply A by whatever it is. Even if you forget all that stuff, it doesn't matter. You can just plug in a point. You know at negative 1, you get out a negative 7. Okay, well now plug in 0 and see what you get out. Plug in positive 1 and see what you get out. you know that you have an axis of symmetry right here. By the way, what is the equation of the axis of symmetry? You were doing so good. It is x equals what for the axis of symmetry? Yeah, it's just whatever the x-coordinate of the vertex is. That would be a good question that they might ask you, to give the equation of the axis of symmetry. It's always just x equals whatever the x-coordinate of the vertex is. Always. Okay, so as far as graphing quadratics is concerned, let's just look at the one they have on here. So 106, 107 in this packet. They're asking you to fill this in over here. You can if you want to. But if I'm going to do this, I know it's going to be up like a cup. And I would start off by finding my vertex, negative b over 2a. So that's going to be 4 over 2 times a is 2. So it's at 2 comma something. Right? And then I'll just plug that back in and see what the something is. So plug 2 in. That's 4 minus 8 plus 1. Negative 4 plus 1, negative 3. So now I know where my vertex is, at 2, negative 3. And then this one, since a is 1, I can just follow the pattern. Up 1, mirror it over, up 3, mirror it over, and then up 5 if you want to do one more. And that should be my beautiful graph. Let's change it a little bit. What if the original was not an equation, but it was one of these? Y is greater than or equal to that. How does that change the graph? Right, if it's first of all, I'm going to graph it the same way that I would normally. I'm still going to do negative b over 2a the whole 9 yards. Get my graph. But now I'm either going to have a dashed line or a solid line. What do I need for this one? Solid. If it has the or equal to bar underneath it, it's a solid line. If it didn't, if it was just greater than or less than, it's a dashed line. So I still have that. And then the only other thing that you would have to do is shade. And I better shade the right way. That's what you're going to see on the multiple choice. They might have all 4 graphs in the exact right spot, but maybe 2 of them are dashed and 2 of them aren't. So that should be an easy pick between those 2. And so now you're going to have 2 that look like they're right. They're both dotted, but one's shaded one way, one's shaded the other. So we better make sure we know which one to pick. In this scenario, where would I shade? Well, let me start off by reminding you there's 2 regions of this graph. Inside the parabola and everything outside of the parabola. So if y, yes, in this case I would shade inside. Here's how we remember. I taught you to put your pencil on the vertex. And then you just read right here. It says y is greater than. So where the y is greater, isn't that above? Right? So I just shade whatever is above the vertex. So in this case, it's all this. Does that make sense? If it had been less than or equal to, I would have shaded everything outside because less than would be down from the vertex, right? So I would have shaded everything on the outside. Yeah? So why don't you guys try 107? The graphs are a little hard to do up on the board, so just try it 107 at your seats. Get the graph. Oh, and you know what? Let's change it. Let's make this one. Let's do another greater than or equal to. What should your graph look like before you even start? It's got to be down like a frown. If it's not, something is wrong. Did everybody get 1 comma something for their vertex? When you did negative b over 2a, did you get out positive 1? That's the first step. The next step is to take positive 1 and plug it back in correctly. This is probably one of the most common mistakes in all of algebra, I'd say. It's right here. When you plug 1 in, right there, when you do this chunk right here, it's negative 1 what comes out, not positive. Why? Because you're doing 1 squared and then take the opposite. It is not the number negative 1 squared. You're not squaring negative 1. Your number is positive 1. So you need to square positive 1 and then take its opposite. So you should have negative 1 plus 2 plus 3, which means your vertex is at 1 comma 4. I bet you anything they will have a graph that has its vertex at 1 comma 6. And you're going to think that you're right, but you are wrong. Okay, so now I have mine at 1, 4. And a is 1, it's just negative, so I can just follow the pattern, but go down instead. 1, 3. You can always double check yourself. Plug in 0, you should have a positive 3, right? Oh yeah, I do. 0, 3, yeah, great. Oh, before I connect these dots, should it be a smooth or, dotted or solid? Solid, because I do have that or equal to bar. Solid. I put my pencil on the vertex and then I go back and I look for shading. Y is greater than, so I should shade up, which in this case is everything outside of my parabola. That's what you should have come up with, I'm hoping. Okay, the other thing that was in this unit, way down at the bottom there, the 117, the word problems with quadratics. So let's read and see if we can figure this one out. The height of an object t seconds after it is thrown from a height of h feet is modeled by the equation blah blah blah. If the ball is thrown from a point 6 feet above the ground with an initial velocity v of 30 feet per second, how long will it take for the ball to hit the ground? Okay, I think that we're going to be giving you the equation with these values already plugged in. So don't worry about that part too much, but I mean, even if they're not, it's not that bad. So here's this random equation, but what do you suppose, what does T stand for? Time, right? Time. How long will it take for the ball to hit the ground? It seems like I'm going to be solving for time, right? So I don't know what the time is yet, so time's going to stay in there. V, well, didn't they give me V? Yes, right here. V, 30 feet per second. So I'm going to replace V with 30. And then H, that's the height that the ball started at, which in this case is 6 feet. So again, I believe we're probably going to give you the equation already filled in, but just in case it's not that unreasonable for you to get there from what's given. Okay, so now I have this equation, and the question is, how long will it take for the ball to hit the ground? So remember the scenario. Someone's standing here, they have a ball that's 6 feet off the ground already, and they're going to throw it. I'm trying to find when that happens. How do you do that? What does it look like I'm finding? If this is turn this into a graph, what is this? What's the name of this thing? It's a parabola. And didn't we learn right here that parabolas can cross twice, once, or not at all? And so to find that location, didn't I solve the quadratic? That's all you're doing. I just have to now solve this quadratic. Well, when we were solving quadratics, the whole thing was equal to 0. Do you think that the height would be 0 when it hits the ground? Yeah, so I'm just going to replace that with a 0. And now, guys, it's a problem just like you had in the last unit. You just have to solve for t. If I were you, I'd start off by dividing everything by at least a -2. And then you could try your t's. Let's try them. I don't know if they work on this one or not. Trying to get to -15. No. Yeah, I don't think we can factor this one. So we'll probably just have to use quadratic formula. I get 321 for the discriminant. So this I would want to turn into a decimal. So I'd have 15 plus the square root of 321. And I would divide that by 16. So one answer I get is 2.06. And then the other answer would be -0.18. Do I keep both of these answers? Right, and I meant t is not x's, because t is time. I can't have negative time, right? So if you look here, that means after just over 2 seconds, that's when this thing will hit the ground. What if I had asked you how high the ball would have ever gone? How would you have found that?
Vertex.
Yes, the vertex. Now, what part of the vertex? Remember, it's in the coordinate, x comma y. Which one of the two would have gotten you how high this ball ever got?
X. Y.
The y coordinate. X is time, right? Y is height. So if I had asked you how high the ball ever got, you'd find the vertex and it'd be the y coordinate. If I asked you when does the ball reach its highest height, it would have been the x coordinate. Okay, so